So in this problem, we're looking at a compound interest exponential function problem or exponential equation problem. We need to remember the formulas for such. Uh, remember when it's not continuously, the formula is going to be A equals, so the ending amount equals the principal amount, the initial amount, times 1 plus the interest rate divided by how often it's compounded, times how often it's compounded, times the total amount of time. Typically in years, unless we're given a specific problem in which it's a different situation. So where is each one of those in our problem? We're told Angela invested $15,000 in a savings account. If the interest rate is 4%, how much will be in the account in 10 years by each method of compounding? And we're given quarterly, monthly, and continuously, which will work out separately. So let's identify the different parts. Where is the ending amount? Well, that's the part in question. What's the principal amount? That's the initial investment. So that's $15,000. That's P. Where's our rate? Well, that's 4%, R. And then N is going to change based on which A, B, or C that we're using. With C, compounding continuously, we're going to use a little bit different formula, but we'll get to that when we get to that part of the problem. And then T, we're given is 10 years, so that equals T. So we have the individual parts that we need. Let's substitute those into our formula to find the solutions for each value. So in this case, compounded quarterly. Well, that means N equals 4. Quarterly means 4 times per year. So substituting into our formula, A equals P, which we know is 15,000, times 1 plus R is going to be 0.04, 4%, so 0.04 divided by N equals 4 to the 4 times 10, NT. So that equals 15,000 times 1 plus 0.04 divided by 4 is going to be 1 plus 0.01, so 1.01. And then 4 times 10 is 40. And if we take 1.01 to the 40th, multiply that times 15,000, we get approximately $22,332.96. And we would always round to the nearest cent unless we're told otherwise. Now with monthly, that just means N equals 12. There's 12 months in a year, so we're compounding it 12 times in a year. That's the only difference between this and part A, where it's quarterly, is the N. So A equals, we substitute into our formula again, A equals the principal, P, times 1 plus R over N to the NT. So A equals, principal is the same at 15,000, times 1 plus rate is the same, 0.04, only this time we're compounding monthly. So we divide that by 12, and then this would be 12 times 10. So that equals 15,000 times 0.04 divided by 12 is going to be 1/30th. Or if we look at it in terms of a decimal, we would end up with a repeating decimal, 0.00333333 infinitely. So I'm going to go ahead and keep it exact at the 1/30th. So I don't have to use that decimal approximation. So this is going to be times 1 and 1/30th. And then 12 times 10 is 120. And then that's going to be approximately, if we take 1 1/30, or 1 plus 1 divided by 30, and take that to the 120th power, multiply that by 15,000, we're going to get approximately $22,362.49. If you notice, those are pretty close. Monthly does yield us just a little bit more, or does yield Angela just a little bit more than compounding quarterly, but not by much. It's just a little under $30 difference over the course of 10 years. Now, with compounding continuously, we're given a different formula involving E, the transcendental number E. So A equals P times E to the RT. Now, P, R, and T are the same. The only difference is that we're using E now instead. So our ending amount, or Angela's ending amount, is going to be the principal amount, 15,000, times E to the R is going to be 0.04. T is 10. So that's going to be E, or 50, A equals 15,000 times E. 0.04 times 10 is just 0.4, or 0.4. So E to the 0.4. And that's going to be approximately 15,000 times E to the 0.4, $22,000, or 22,377.37. So as you can see, increasing the number of times that we compound the interest in a given amount of time does make a difference, but it might not be as large as you think. We're looking at a difference of, if it's only compounded 4 times a year, $22,332.96, and if it's compounded continuously, it ends up being $22,377.37. So in each case, going from quarterly to continuously, the difference is less than $50.